Hello everyone, this is Himanshu, and today let's solve and together, that is coin change. The problem states that you are given an integer array coins representing coins of different denominations, that is 1, 5, etc., and an integer amount representing a target amount of the money. What we have to do is to return the fewest number of coins that you need to make up the exact target amount. If it is impossible to make the amount, return -1. You may assume that you have an unlimited number of each coins. Okay, so the problem states that we have an amount and we have a set of coins, and we have to combine the minimum number of these coins in order to come up with the equivalent amount, with the condition that we can use any coin any number of time that we want, and if we cannot make up such amount, we just have to return -1. So here, like, what is coming up in my mind uh here is dp. So what does it says is we have the amount, and then I think I can think of it as a classical problem of uh so at each point of time I will have the two decisions. The first decision will to take the coin, and the second decision would be to leave the coin, right? To leave the coin, and then we have to come up the number of coins that is minimum. Sure. So here I would like to come up with the top down approach. So what this approach will say is it will say that, okay, what is the minimum of number of coins that I can make amount 1. What what are the combination of minimum number of coins that I can from which I can make the amount 2, and similarly I can extend this to what is the minimum number of coin that I can use to make the amount n. So if this is the minimum from here, since I am from top, I'm just coming down, I can like trace back using a dp array about what is the minimum number of coins that will need for an amount n, right? So let's just move toward writing the base case. So first we'll define an array dp. So here if I think, what will the dp be? So dp will be an amount that will be equivalent to n. So dp, what I will do is will be equal to an array with 0 as a value and size equal to amount plus 1. Amount plus 1. Yeah. So yeah, correct. So what it will say is, it will say that what is the number of uh, coin dp will store, the number of coin that will, yeah, dp will basically tell the number of coins that will make the amount I. So here if you see, dp of 0 will be 0, meaning that we need 0 coin for making anything equivalent to 0, right? And for 1, so okay, these are the coins we have. We don't necessarily have like 1, right? So we don't know what will the 1 will, correct? Now we can iterate for, let's say, I in range 1 to amount plus 1. And here what we do is, so our intuition is we'll take that coin for all the coins. Either we will take that coin or we will take the minimum of all the prior coins possible. So yeah, so what we can do here is we can also iterate through all of the coins that we have. So we can say for coin coins in coin. Okay, so for coin in coins, so we'll take all the coins, and then what we'll do is dpi will be equal to I would say minimum of uh, this will be minimum of dpi and dp, you can say 1 plus, if we are using that coin. Okay, and it will be 1 plus dp I minus coin, right? And yeah, so this is what it is. And here what we can say as well, we can do it only if I minus coin is greater than or equal to 0, right? And just move it here. So I think this is the method and dp amount will be the results. uh yeah, however, what we can do, we can fill it with inf if it work. If let me just check how we can assign anti-max. So it says uh, float int. mm, this. Okay, but what if my list is an integer? So it says minimum. Okay, float int. This is how it is assigned. Sure. So here's the question. Here I've just assigned float of int. So here it goes. So DPS float of int into amount plus 1. So yes. Now for each of the I in range amount plus 1, I will just do this. Just do this. Okay. And one, just the base case will be DP of 0 will be 0. Minus coins. If I minus 1 is greater than 0, DPI equal to minimum of DPI plus 1 plus DPI minus coin. Yes. So here is it. And here, if I will say if DP amount 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 is equal to float int. If this is the case, then we can just simply return -1. Otherwise, we can just return dp of amount. I think, yeah, this is the code that I'm thinking of. Let's run it. Oh wow, this worked. Oh, this worked as well. So yeah, this is the overall implementation. So let us just try to implement it, but using the recursion. So we'll just remove it. Yeah, now we have reset. So now what we'll be using is, we'll be using top down approach. Top down approach. Okay. So this problem is called coin change. And yeah, here is the coins. And for each step, what we can do is either we'll take the coin or we will just skip the coin, right? So there are two options. And if the amount that we are tracking is, or if the amount is 0, we can just say, okay, now it's enough, and then now we want to uh, return from there whenever the amounts get 0, right? So let's come here, and then I'll just do self dot amount equal to amount equal to amount, and then we will just return uh, coin min coin. This function will have uh, our results. So we will just define min coin uh, coin. Yeah, so here it goes. And what this function will have, it will have uh, the index that we are in, that is 0. It will have the amount that we have, self dot amount. It will have uh, it will have our list of coins, right? And yeah, I think that's it. Doesn't need n. Okay, let's here just transfer n, or uh length of coins, and then we'll just minus one. So here what we'll be having is, we'll have the coin, we have an integer n, or let's say we have the index I, and we'll be having amount. uh yeah, and then we'll be having, it should be self out amt. Okay, here we'll be having amount, and then what else we'll be having, we'll be having points, right? Correct. Now let's think about this part. So the base case is, if amount, if self dot, I think when I don't need to pass amount here, because it is globally stated. So I can say that if self dot amount is equal to 0, then we just have to return 0, right? Okay. Otherwise, what if this is not the case? Otherwise, what we have to do is, we have to return minimum of uh okay. Now see, if self dot amount uh is, let's say, less than 0, then if this can, we have to just return float float inf, right? We'll just return very big number, so that it is not possible for them to get this. If it is 0, then we'll just say 0, right? Okay. Okay. Or this is the case less than 0, or it can also be the case that I is less than 0. These are the two cases we don't want. This is the cases that we'll just returning 0, saying that okay, should be 0. Now let's move forward. If these are the base cases, then what is the remaining cases? You have to just return the minimum of two things. The minimum of min this, and min coin. Okay, coin, right? Okay. So let's say if we have taken that coin, so this should be, if we have taken the coin, it should be 1 plus, and then since we have taken the coin, it can be I will be going, and we can have uh and coins, right? Or one thing, or we cannot take the amount, right? So how it can be done is, let's say, take vol when we are taken is, should be equal to min of uh equal to 1 plus min coins, min coin, and it will go I comma coins, right? So this is when you have taken the coin, right? Okay. And the amount, what will be the amount? Before this, the amount will be subtracted. So it will be self dot empty equal to uh, uh, minus equal to, it should be reduced by coins I. Yeah, we'll just remove it, right? And then after this it will be added here. This is what we call as backtrack. Okay, so we'll say mount plus equal to coins I. Correct? Yeah. And then we have the taken wall and we have not taken wall, right? So when we have not taken it, it will be equal to, we have not taken coins, so it will be just uh min of coin, and then since it will be I minus 1 since we are not taken, and then it will go as coins, right? Yeah. And at final we'll just take min of both taken, taken comma non taken, not taken. So yeah, so now we will take the min of taken versus not taken, and they should, we will return. So yeah, just we have to say that, yeah, if this thing, if this one is equal to float infinity, then we can just return this one. We can just return float. This should be a over. There's some error over it, and which 20th case is failed. So let's do one thing. Count we can say as this x. Then we can just use this as a count. Yeah. Here the error is, what the error is, maximum recursion depth exceeded. The repeated 994 times. Okay, maybe if I submit here then. Mhm. It should work because here the error line that we are getting, uh, okay, everything is working here. Here it is showing an error. The problem is it cannot be equal to this one. This is not necessary, that one. Okay, if let's say if we do uh, so say if you do coin count, okay, if you do is say is greater than minus some big value, and then we submit. Your output was INF, but expected return type is integer type error. Let us make equal to and then just run. I submit it. The error is here. Here says this one has maximum recursion depth exceeded. So why is recursion depth is exceeding? Or if I is less than 0, right? So here we are adding 1. We are reducing the amount. That's also good. And then okay, now I see. So we can do this, or we can just not take it. So we'll just move I to -1. That is also good only. So self dot amount is less than 0 or I is less than 0. Is there any error there? This should work. I'm not sure. Let me just ask ChatGPT. Okay, saying that to pass this as a parameter because yeah, we also don't need it, right? And that should be passed parameter. So if taken, not taken, then just return the minimum. That does make sense. So yeah, this should work. Just look at this. Okay, so here I'm getting error because I'm just using recursion. Now I understood. I think I was right there at that time as well. But the only issue is since we are using recursion, I also need one dp. This is correct. Before calling the function that is here, I need to have one dp, and I want to have dp as self.dp, and that will be a map. So there is ij. So okay, amount is j. What is I? I the length of the coin, right? So what I can have is n should be equal to the length of coins, and then I have to create dp, and let's say the value -1. The size will be I, or here n, and yeah, this will be for this in range amount plus 1, and yeah, this is the 2ddp. So once it's done, what I can do is, uh, here we have written 0. So basically what I can do is, okay, that's fine, this is also fine, but here we can, what I can do is, I can say dp is equal to, so dp I and dp amount will be equal to this one that I am saving, and here I can say if dpi amount is not equal to -1, you can just return dp of I or n amount, right? Let's run it. dp is not defined. Okay, there should be self dot dp. Here also should be self dot dp. Now run it. So dp amount is list index out of range. Okay, what is the error here? The I and amount cannot, both of them cannot pass here, right? So maybe self dot dp. Is this the error? Okay, now let me check. List index out of range. Cannot see the error here, to be very honest, because I and j are have the same length, and I can be 0. I cannot be less than 0. So what is the error here? So db dimensions are reversed. I see, meaning that this will not create n. Then there will be no. Okay. So this is n is this one, right? But this one we want as amount, right? So this is the column. This should be I. Wait. अबे so yeah, we checked. If that is not there, we just replaced it. Uh, sure. Then what was the error there? If I see, these are also getting error. This is what I think. I see. This is something that I was not aware of. Oh my god. Nope. Check out the solution now. 1e9. Okay, that's the better option. So, okay, this is also makes sense. Turn amount, this also makes sense. DFS just has an amount. If amount is zero, we just have to return zero. Otherwise, rest equal to itna. For coins in coins, if we check if okay, this and for coins in coins, if the amount is greater than zero, what we will do? Just take that coin. Makes sense. Yeah, it should be this only. I should have understood right when I have written the DP programming in that way. I should have understand there only that there is just amount that is being changed, right? So I should have understood it. That was my fault. I get it purely. because there's just amount. There's just one parameter that is being changing, nothing else. As simple as that. What? This one. My goodness. This one is running. This is the same complexity. O N T N T. Look at this. O N T N T. So crazy, man. If nothing is working, then what is working then? Okay, sure, guys. This is all from my side. See you tomorrow.